Section 5.5 is performing function operations. So let f and g be any two functions. A new function can be defined by performing any of the four basic operations on f and g. So if we do addition, we can say that f plus g of x is the same as just taking f of x plus g of x. If we take f minus g, so subtraction of x, that'll be f of x minus g of x. Multiplication, which would be f times g of x. Again, it's kind of just showing we can separate them. So we can say it's f of x times g of x. And then division, we will have f divided by g of x. We can write that then as f of x divided by g of x. And that's what we're going to kind of do today. So I have 4 examples. I'm doing addition on the first one, subtraction on the second one, etc., etc. So the domain consists of the values of the x values that are in the domains of f and g. The domain of the quotient does not include the x values for which g of x is equal to 0. Remember, when g of x is equal to 0, if it's division, it's not going to work. We're going to have an error on our calculator. So let's go ahead and look at the first one. So let f of x equal 5 times the square root of x, and g of x equal negative 8 times the square root of x. Find f plus g of x and state the domain, then evaluate the sum when x is equal to 16. So on this one here, what they're telling us is we have f plus g of x, which we can, again, I'm just writing down the formula up above, which we can write as f of x plus g of x. So our f of x was 5 times the square root of x plus a negative 8 times the square root of x. So, again, if you want to just think about it, plus a negative is a negative. And that will give us negative 3 times the square root of x. Okay, so our domain of f of x is, again, all real numbers, or actually from 0 to positive infinity, not all real numbers, because, again, we can't have a negative under the radical sign. So remember, we would write that as x is greater than or equal to 0. The domain of g of x, again, is the same. Remember, that's the function notation that the college wants, but I'm sure big ideas will want x is greater than or equal to 0. And then the domain of f plus g of x, again, that one's not going to change on this one here. So we can say that it's, again, from 0 to infinity. Remember, the bracket means it includes that, or again, big ideas will probably have us do x is greater than or equal to 0. So now we're going to just plug that in. So now remember, we need f plus g of 16. So if we take our f plus g of x, which was negative 3, times the square root of, well, we're going to put 16 in for our x, and the square root of 16 is 4. And so our answer is negative 12. Example 2. Let f of x equal 2x cubed plus 4x squared minus 8x plus 4, and g of x equal 3x cubed minus 5x squared plus 6x minus 9. Find f minus g of x and state the domain, then evaluate the difference when x is equal to negative 1. So we're going to do the same thing as we just did up above. They're asking us to find f minus g of x. And we know that we can separate that, so we can say it's f of x minus g of x. Okay, so our f of x is 2x cubed plus 4x squared minus 8x plus 4. And then we're going to take and we're going to subtract all of the g of x. So that's why I'm putting it in parentheses. Okay, so now we know that we're going to have 2x cubed plus 4x squared minus 8x plus 4. And I'm going to take and I'm going to distribute that negative through the parentheses. So I'll have negative 3x squared plus 5x squared minus 6x plus 9. And then we're just going to combine like terms. So I have a plus 2 minus 3, so I'll get negative x cubed. Sorry, that one's cubed. I have 4x squared plus 5x squared, so that'll be plus 9x squared. I have negative 8x minus 6x, which will be negative 14x. And then I have 4 plus 9, which will equal 13. Okay. So the domain of f of x is equal to negative infinity to positive infinity, or all real numbers. The domain of g of x is the same, so it's negative infinity to positive infinity, or again, all real numbers. Yes, dear?
Any cup?
I'm almost done. And I'll have domain of f minus g of x. And that one is negative infinity to positive infinity, or again, all real numbers. So now on this one here, we need to do, again, let's go here. Let's see. Let's go f minus g of negative 1, which will be, again, I'm just going to plug in negative 1 wherever I see x. And if I work that out, ladies and gentlemen, I'll get 1 plus 9. Negative times a negative is positive, plus 13. So you should get 37. Example 3, let f of x equal x cubed, and let g of x equal the square root of x. Find f and g, f times g of x, and state the domain, then evaluate the product when x is equal to 4. So on this one here, we can say f times g of x is again f of x times g of x. Let's make that look a little more like a multiplication dot. So that'll be x cubed times the square root of x. So now remember, I can write the square root of x as x raised to the 1/2 power. Okay, so then that will tell us we have x. And again, when the bases are the same, you can add the exponents. So when I add the exponents there, remember 3 we can write as 6/2 plus 1/2. So we'll get x is equal to the 7/2 power. Okay. Now remember, as an aside on there, you can write that as either x, the square root of x raised to the 7th power, or the square root of x, and then the 7th power would be on the inside. We might need to know which one looks better as we go on. So let's go ahead and see what's our domain of f of x. Well, f of x is x cubed, so we know it can be anything. So that would be negative infinity to positive infinity, or all real numbers. The domain of g of x, remember, it's a square root, so we can't have a negative under the radical. So again, on that one, it would be x is greater than or equal to 0. And same thing here. If I look at that one there, that's telling me that I can't have a negative under the radical. So there I'm going to have, again, the domain of g, f times g of x. That'll be 0 to infinity, or again, x is greater than or equal to 0. And then they want us to do it when it's 4. So f times g of 4 is equal to, again, it doesn't matter which one you put it in. I think I'll put it in the first one because that one looks easier. Because again, I know that the square root of 4 raised to the 7th power I can write as 2 raised to the 7th power. Plug that into your calculator. We'll get 128. And finally, the last one here is let f of x equal 4x and let g of x equal x raised to the 2/3 power. Find f of f divided by g of x and state the domain. Then evaluate the quotient when x is equal to 27. So on this one here, you're going to have f divided by g of x is the same as f of x divided by g of x. So on this one here, we'll have 4x on the top. On the bottom, we'll have x raised to the 2/3 power. And remember, on that one there, when the bases are the same, I can take in 4, and I can have x, because I'm just taking this part right here. That's going to be x raised to the first power minus 2/3. Okay? Or you can write that again as 4. It's going to be x to the 3/3 minus 2/3, common denominator. So that will give us 4x raised to the 1/3 power. And let's see on that one, what's our domain for f of x? Our domain for f of x is, again, negative infinity to positive infinity, or again, all real numbers. The domain of g of x is the same. It's going to be negative infinity to positive infinity, or again, all real numbers. And then the domain of g of x, f divided by g of x, I'm sorry. As again, it's going to take the same one, so it's going to go negative infinity to positive infinity. And again, all real numbers. But again, on this one here, you have to state x cannot equal 0. If x is equal to 0 right here, that's going to make it be undefined. All right. If it was x plus 2 underneath there, then x can equal negative 2, because again, that would make it equal to 0. Remember, that's the kind of thing we're looking at. And then on this one here, they asked us to find f divided by g of 27. So on that one, we can take 4 times 27 raised to the 1/3 power. The 1/3 power is the same as the cubed root. So what is the cubed root of 27? It's 3. So then we'll get is equal to 12. There you go. I did one of each. I think on the homework, it has you do 2 of them on each one.